Okay, welcome to another episode of the On.NET Show. And here today we are lucky to have Mads Torgerson. Yes, you.
Oh,
and,
hey.
and we're going to talk about lesser known features in recent C# versions.
Mm-hmm.
So thanks for coming to talk with us.
Thanks for having me.
Yeah, so you're the language designer for C#. That's right, isn't it?
I'm one of them. Yeah.
Yeah. Awesome. So yeah, you know this stuff.
I know a bit.
Yeah. So today we're going to talk about some things that people might not know in recent C# versions.
Right. Yeah. We have. We had a major release last year, C# 7.0, and then since then we've actually had a couple of point releases, which is unusual for the language, where we added smaller but interesting features. And across both the major version and the minor ones, we added things that many people might not be aware of, and they're sort of not the blockbusters that tuples or pattern matching are. Those are the ones that you will kind of focus on when you say, what is C# 7 about?
Yeah.
So those are the ones we won't talk about today.
Okay. Now remind me, so you said, so there's been 7.0 and there's definitely been 7.1. Was there a 7.2?
There was a 7.2 as well.
I actually did not realize that.
Right. It's going so fast now that even Richard Lander cannot keep track.
Yes.
So, So sorry about that.
That's okay.
The 7.2 release was motivated by aligning with some work that was going on in the framework and runtime around span of T, and in general around making low-level programming safer and more efficient, or rather making efficient programming safer or safe programming more efficient, or whatever you want to say, right? So, so there was sort of like a cross-stack effort that also bled into the language sum, and that was the main motivator for even putting out 7.2. And then just to kind of, because we haven't done point releases forever.
Never.
We just to kind of warm ourselves up to that and kind of get the gears rolling on what is a point release even. We had a small one, which was 7.1, which was really just a few convenient features to see if we could do point releases.
Mm-hmm.
So,
makes sense.
So a bunch of what I'll show here today is stuff that relates to that value proposition of the safe, efficient, low-level code that we decided to focus on.
Right. And just before we do that, who would you say this particular feature is for? Is there like a category of folks?
Yeah. Normally we try to do features that are for everyone.
Yes.
And these are for everyone, but they're more for people who build libraries and frameworks probably than they are directly for people doing app development.
Yeah.
In that they typically have to do with you'll use them when you're doing buffer management or parsing of payloads or something like that. That's where they really shine. But in people in those categories using those to make the frameworks and libraries safer and more efficient, it benefits everyone sort of at the next level, right?
Right.
If you're a consumer of those APIs, you're now a happier consumer.
Right. Now, is another way of thinking of it is, if I'm the type of developer who only uses collections and dictionaries, then this is less for me. But if I use and copy around segments of arrays, then maybe I should pay attention.
Absolutely, yes. Or if you're like a game developer and you work with structs a lot because you don't want to allocate, these features are also for you.
Yeah. Okay. So let's dig in.
So let's see here. So to start out with, in C# 7.0, I already put this in my code here, we added ref returns.
Right.
So this is definitely aimed at people who want to work with big structs, to make it easier for you to write functionality. Say I have a big struct array of objects in a space game, and I want to get a particular asteroid. Now I can have a method that returns me a ref to the struct that sits in the array, rather than copying that struct out and wasting resources.
Right. So one thing when this feature first came out that I didn't quite get is that you can explain is I always thought of, I guess this is because it's a struct. I always thought of I return something. Most of the time I'm using reference types. And I always thought of well, it's a reference type. I'm returning that by reference.
Yeah.
The caller should get everything that I passed, not as a copy by a reference. Is this specifically oriented around you're returning a struct instead of a reference type,
Yeah,
or can you use it with reference types
You can
too?
use it with reference types, but it's most interesting with structs.
Yeah.
Because for a struct, if you return that in pre-C# 7.0, you have no choice but to copy the struct.
Yeah.
And if it's a big struct, like a big asteroid,
Yes.
you don't want to copy it.
Okay.
You want to just return a ref to the place in memory where it is.
Yeah. Now, does it have value for reference types as well?
It has a little,
Okay.
but it's less value. What it does, it returns you a memory location, so essentially a place where there's a variable or an array element or so on that you can then assign to. So if you want to give people a memory location to stick a string in rather than just return the string, like here's a place where a string sits, and now you can modify it if you want to. It has some utility like that, but you have to be a little more creative to come up with the scenarios then.
I see. Okay.
Okay.
Makes sense.
Yeah, so that's C# 7.0. That came out last year, and that was sort of the first in a series of ref-related features.
Yes.
And you see what I get here? I have a silly little method here that takes two refs to ints, so two storage locations that have ints in them, and it modifies both of those ints, and then it returns a ref to one of them. So returning a ref is the new thing that you can do.
Right. So clearly, the ref that exists in the right-hand side of the method signature, those are not new.
Right.
The ref that it's on the left-hand side, I assume the semantics are exactly the same
Yes.
as the ones on the right.
Yes.
Okay, good.
Just going the other way.
Yeah.
Going down the stack instead of up the stack,
Yes,
or
okay.
whichever way you view it.
Yes, perfect.
So what you see here is I create two variables. I pass them by ref to my method. I get one of them back, I don't know which, and I can store that in a ref local. So now I have a variable z that is pointing to the same memory location as x or y. And that means when I modify z, when I write 100 into that, then I get that 100 into either of these two variables.
Okay.
Right? So if we run it, which writes them out, you can see that
Something.
I have an error.
I'm guessing that wasn't part of the demo.
Oh no, that's because I must have done some. Oh yes, let's just delete this stuff. There we go. So let's run it again. That was a part of my demo for later that I stuck in there and didn't check that stuff compiled. So you can see x changed to 100, even though I made the assignment to z, because z is a ref to the variable x.
I see.
So that's the main point of all that. You now get to trade in storage locations.
Got it. I have a question, this may be like a language designer question. So I see the ref that's on line 16 that's just before or maybe.
Mm-hmm.
I understand why all the other refs are there.
Right.
Why is that one there?
That one is there to signify that this is a ref assignment. Right, so this assigns the ref, not the value, and so think of it as I'm assigning I'm assigning the storage location into something. I'm not assigning the contents of the storage.
I see. This might be a bad analogy, but it feels a little bit like when you put a cast to the left-hand side of something. You're basically saying this is the nature that I want it to be. It feels somewhat similar.
Yeah, you're right. That's a bad analogy.
Okay.
No, it's sort of opposite to what you do if you're in a language or in unsafe code where you use pointers and dereference, right? There you're trading in the pointers, and then you have to do something explicit to dereference them.
Yeah.
But in C# we're stuck with a syntax where you're dereferencing by default.
Yes.
When you assign from a variable, you are assigning the contents, not the variable. And so we have to put syntax to stop it from dereferencing.
Yes.
And that takes a little getting used to.
Yeah.
So that's the essence of that feature. And then in C# 7.2, when we wanted to do more for this scenario, we added various little refinements around refs. Okay, so the first one is that something that, by the way, VB was always able to do, is that a ref parameter you can now use that for an extension method. So I can put extension methods on structs that work by ref, which is important because so let me do it. So I'm making this an extension method on ints passed by ref, which means that here I can choose to call x dot or maybe, and then delete x as the first argument here, and then x gets passed by ref to the extension method. And that's something,
I see.
something people have been clamoring for a long time, because up until now in C# you couldn't put an extension method on a struct that would mutate the struct, because the this parameter had to be a value parameter, which means that it was copied. You copied the struct, then you mutated the copy in the extension method.
Which is bizarre.
And then you threw it away when you returned, right?
So not super useful.
So this finally makes extension methods useful on structs.
I see. Interesting.
So that's one little thing we added. Another is that a reason why people are sometimes hesitant to use refs is that because they're passing a storage location, somebody else might mutate that storage location. You might just want to you might want to pass it by ref for efficiency. Like, you don't want to copy the whole thing, but you don't want them to muck with it. So we also wanted to add a way that you can pass things by ref but prevent them from being mucked with.
Okay.
Okay, so if we do it on the returns first, you can declare the ref return here as read only.
Okay, that's what I was expecting.
Yeah.
Yes.
So I'm returning ref read only, and now you see immediately I get a complaint down here that I'm assigning a ref read only to something that I can mutate through, but I can make the local variable ref read only as well, and then that bug goes away. But now I can't mutate it. You see the assignment to Z is no longer allowed. So this returning it ref read only prevented the caller from mutating what I sent to them. I gave them this ability without giving them mutation rights.
Wow.
So that's pretty cool. And you could do that the other way as well for refs coming in. But there, after much deliberation, we chose a different syntax. Instead of, we could make you say ref read only here, or we could allow it. Well, especially if I could spell it,
yes.
But it doesn't really matter. It's still not allowed. What we did instead was we said, well, passing something ref read only, that's really the opposite of an out parameter. It's an in parameter.
Okay.
Because an out parameter, you pass a variable and you expect it to be assigned to, right?
Yes.
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 And an in parameter, you pass it by ref and you expect it not to be assigned to.
Yes. And for it to have a value already.
Yes, and for it to have a value already. And so we call these in parameters, and I can put in on these as well. And that means now that my method body is prevented from mutating them.
Right. Now, yeah, that keyword didn't exist in that location before. That's correct, isn't it?
That's correct.
Okay,
yes.
just checking.
Yeah.
Because all we had was out and ref.
Out and ref. And now we added in, which was a keyword already, but not there.
Yeah, that's why I said in
so
that spot.
We like reusing keywords wherever we can. So now these assignments are disallowed. But you can also see that I'm not allowed to pass things by ref to it. Just like with an out parameter, you have to say out. With an in parameter, the keyword you have to use is in. Okay?
Yeah.
So now I'm passing y by in
right.
as an in parameter, and now I know, and it's evident in my source code, that it's not going to go there to be mutated. Y is going to remain the same after I made this call. I protected it.
Right. Now, in this example, we're dealing entirely with structs / value types with these in and out parameters. Like within, can you use that with reference types as well, or is it?
Yeah.
Okay.
So just like ref, just like out, just like we talked about before,
yeah.
all of this works with storage locations regardless.
Okay.
It's just that it's more useful when applied, more useful when you're working with structs, in particular when you're working with big structs, which I'm not here, and then trying to prevent them from being copied.
Yeah. Now, immutability is an important concept. We have, various forms of immutable collections and other types of immutable data types in the product now. If you were building one of those from scratch, would any of these features be relevant for that as part of your implementation?
They definitely could be, even as part of my public interface, actually. So let's say that I'm providing an indexer into my collection type, and let's say it's generic, but it can be instantiated with structs. Again, an indexer that you write today, or pre-C# 7.2, you would write as a, it would return a copy of the value that's in there, which would protect from mutation, but it creates a copy.
Right.
But you could instead return a ref read only to actually the variable inside of the array that you have in your implementation of the data structure, or whatever you use to implement it.
Exactly.
There's a storage location in there somewhere that holds the value, and you could return that out of your indexer as a ref read only.
Yeah.
And then people get to observe the actual value in its actual place inside of the data structure, but they can't muck with it.
Yeah, because that's one of the things I've always thought was odd about some of these immutable structures, especially like if you had an immutable array, it's only immutable kind of in one way. As soon as you go grab, like imagine it's an immutable array of some reference type. As soon as you grab that reference type, you can party on that object.
That is true, but that's still true with this. There's no change there. That's sort of like shallow immutability that says that the collection itself can't change, but the objects inside can.
Right.
And so this doesn't really change that.
Okay. Makes sense.
So that's most of what there is to say. There's a nifty little thing, which is that semantically passing something by in and passing it by value, just copying it, isn't all that different. Right? You're passing something in, and it doesn't change. Okay.
That's true.
And so it seems like it's just a more efficient way of doing it when you have large values. And so for that reason, we actually let you not give the in keyword. It's not, because the reason we have these ref and out keywords there is to warn the caller that something might happen to the thing they're passing in. And something might not happen here. So why require the in keyword? And not only that, but you can actually put something here that's not a variable here or here as a receiver for an in parameter. You can put any old expression, and what the compiler will do is it'll create a new storage location, put that value in that storage location, and send that by in up here. And so you can see that there's actually a third. What gets returned to you now as z is actually a third storage location that was created for this parameter. You can see if we run it, you can see that that there are now 3 different variables with 3 different values.
Makes sense.
So anyway,
just one question: you said you don't actually have to specify in that case. Is the reason that it continues to be in is the fact that the method signature for or maybe dictates that?
That dictates that.
Yeah.
Yes.
Okay. Good.
So.
Have you seen any evidence that people are actually taking advantage of this feature?
It's early days yet,
but
we certainly know that the people who are working on span of t and the set of types around that, they make a lot of use of this. This is integral to those types. And so it's not accidental that we do these things now. It's not just to help out people with this, but it's also to create the foundation for span of t.
I see. Now, do the span of t people use this for performance reasons or more on the safety side?
It's that combination.
Okay.
It's being able to return you something in a performant but safe way, for instance.
Okay.
There's something called a read-only span. It gives you access to a storage location or a set of storage locations somewhere, but it gives you read-only access. And then if you index into it, then you get exactly a ref read-only back from that indexing. So we actually do use that.
Okay, makes sense. Now, can you remind us, I think there's some special thing that you have to do to opt in, or first question, with the stuff you just showed us, is this 7.2 or 7.1?
7.2.
7.2. And then can you remind us how to opt in to 7.2?
Yeah,
so I think you have to do something special.
The easiest way to do it is first of all, you need to have Visual Studio 15.5 or greater.
Okay.
If you have that and you start using one of the features and you get an error because it's defaulting to C# 7.0, there will actually be a code fix that allows you to upgrade to the latest version of C#.
Okay.
So there is a menu in there somewhere. I can't even remember how to find it. It's not that hard, but in the settings somewhere for the project. But the easiest way is to just use a feature and say yes to being upgraded.
I see. Yeah, when I can't remember what the first 7.1 feature was that I used. I did use something. It was either async main or something else, and I went the other route. I had to.
Right.
I think it's in project properties.
Yeah, I think so. It's not super buried.
No.
But more and more, I find myself, that's just plugging the IDE experience here, I find myself not going to add references much. I don't go to the project settings dialog much, because more and more often, you do something and it wasn't right yet, that's a code fix that offers you, oh, let me go reference that and put a using up here, or let me
Which is
let me
awesome.
go switch this for you so it works. So more and more you can just be in the code and get those things done.
Which is great.
Mm-hmm.
Okay, well, this was awesome. I definitely learned some things I completely didn't know.
Cool, and that you might not ever need,
Yeah,
but,
might
but
not
it's
ever
certainly
Well, one thing is I'll sometimes be on GitHub. I'll see this code file, and readability is super important. So I may not have ever written this code, but it's super helpful for me to be able to read it to understand what it's doing. Remain literate, basically.
Right. And if you become a consumer of span of T, which I think a lot of people will over time, then you will start to see these things in the public interface of those types. And it's good that you understand what they are.
Yeah, absolutely. Okay, well, thanks for coming by and showing us some new and kind of slightly off the beaten track features.
Cool, awesome.
Awesome. Okay, that was another episode of the On.NET show, and we learned a little bit more about C#. Thanks for watching.